Here we go. We're back. Let's talk reliability, validity, defensibility. So part of this is kind of review within a new context for you, given for most of you either business or psychology backgrounds. The university, for the large part, is about teaching us about statistics, let's face it, regardless of the area we're in. And now we're going to explore that as it applies here. And also notice that this still ties to the find measure assignment and other assignments that we'll be looking at, the activity level assignments. So we're going to talk about reliability and validity first, then we'll move on to defensibility. We'll wind our way through these ideas. So reliability, unreliable measures give us information that's meaningless or useless. Right? So if the measure is undependable, unreliable, then we might as well not use it at all. Reliability is kind of at the core of a measure. Validity, let's put reliability first. So it's something that we always want to assess and look at. The questions when we're trying to determine reliability is, does our measure consistently yield the same score for the same person over time? Does it do so under different conditions, and does it do so administered by different people? Now, in the last module, I talked about the IQ test as being well normed and an extremely reliable measure. Let me give you an example. When I was about, third grade, I was about 8 years old, give or take, I transferred from Burbank schools in Los Angeles to Los Angeles City schools. So I come to this new school, and Los Angeles doesn't trust Burbank for whatever reason, their silliness, and they say, we want to give Mark an IQ test. So they gave me an IQ test, and it was an IQ test that I was given. I sat across a desk from the tester. I remember the woman, and it was in large part a behavioral test. That is, I would do things as she asked me to do them. So that was about third grade. And then when I was about 15 years old, my mother was concerned about my behavior. She sent me to a psychologist, etc. And part of that, the psychologist then recommended that I be tested for my abilities, etc. And that was also an IQ test. So I took an IQ test, I think that was at age 15, maybe 16, right around there. And then at some future point, I took a test to join Mensa or some such organization, and that involved an IQ test as well. So I took 3 different IQ tests in 3 different formats. My score was in 3 points on all of these tests over this period of time. And I'm going, holy shit. Regardless of the form, the norming, this test is reliable. Imagine you take a test 3 different times, right? 3 different types of tests, and yields the same score. Let's say that the IQ, the intelligence quotient, is a well-developed construct, and we've proven that we can reliably measure it. Now, the issue is, does it frickin' predict anything, and especially would it predict on-the-job performance? That's when we get into the idea of validity and then building a case for its defensibility, right? So it's got to be reliable. If not, we have big problems. Our data can't be relied upon if the test that's generating that data is unreliable, right? So you can imagine if we're developing a COVID test, and this is one of the things that a lot of people who don't understand science don't understand. We're going to develop a COVID test. That's fine. Develop what you think is a working COVID test, but is it reliable? Does it produce the same score on multiple retests, right? Under different conditions, maybe different temperatures when the test was conducted, right, or by different people. I know everyone wants to rush to a COVID test, but we really have to think in terms of the COVID test as being reliable or unreliable, because if it's unreliable, I don't know what the point would be, right? So how do we test reliability? Well, sometimes if we have 2 different people administering a test, and let's say it's a behavioral measure, or we're observing, right, and we have 2 observers, observing the candidate perform this task, so we have a behavioral measure, and they're both using the same rubric, they should both be using the same rubric to score the test, then what we do is after they score about 20 people, we compare both raters' reliability, that is their inter-rater agreement. And typically we're looking for a number that 75% of the time or more, two separate raters who've compiled their ratings separately demonstrate agreement. And those of you who've done coding in the laboratory, there's usually two people who are coding behavioral phenomenon, and again, inter-rater reliability is going to be assessed. Now, Cohen's kappa is a more detailed measure of agreement that accounts for chance agreement, because there will be a certain amount of chance agreement, so it can then bring that into part of the picture. Cohen's kappa is something you would learn to use if it becomes necessary. For most of us, though, if we're selecting pre-made tests, and this gets back to your find measure assignment, I don't necessarily need to run the test. What I need to do is look at the literature on the test and determine from that literature if they're discussing reliability, and how do they then discuss that reliability. So that becomes critical in that part of the assignment, right? So, types of reliability, test, retest reliability. This is where I give someone a test and then I wait some interval, I give them the same test over again, and then I can compare their score from time 1 to time 2. And the closer their scores resemble each other, then we would consider the test to be more reliable. What do you think might be the downside of that? Well, we have practice effects. That is, if I take the test once and I actually remember my results on the test, then I could duplicate those quite readily, or I could do better on the test the second time. So test-retest reliability is kind of questionable. It might be better on behavioral measures, right, rather than pencil and paper measures when you get right down to it. Now, alternate or parallel form reliability indicates how consistent scores are likely to be if the person completes 2 or more forms of the same measure. That would be my earlier IQ test example. The problem with this, though, is that do we know that these tests are identical, the 2 different tests that we're comparing the scores on to determine reliability, and that becomes a debatable issue. Internal consistency reliability indicates the extent to which items on a given measure assess the same construct. So if we're looking at a measure on extroversion and we have 20 items, to what extent do all the items on that test correlate or tap into the construct of interest, let's say extroversion? And we already discussed inter-rater reliability, indicates how consistent scores are more likely when they're scored by 2 raters using the same scale or instrument. I should say maybe a little more about the second one, alternate or parallel forms of reliability. Often if we have a test where we have 20 questions, then we might, and this is called split half reliability. We take 10 questions, we give it to the person, then at some other point in time we give them the other 10 questions and we correlate the scores on both the split halves, right? Obviously the problem with that is, are the 2 halves identical, or how identical are they? And that enters into our assessment of reliability. Now, threats to reliability, maturation, that is, testees gain experience. So if we do the test-retest, this might then be problematic because of maturation. Training is kind of the same issue. Test serves as a training device. The first half of the test people learn from and then improves their performance on the second half. And then history. When we look at tests over time, the world is different, right? And sometimes major incidents can occur that change people. Sloppy haphazard testing procedures are also threats to reliability. So when we look at interpreting reliability coefficients, and this is something that if it exists I would expect you to be able to find in the find and measure assignment. If you're interested, let's say, in using, we'll pick on the Myers-Briggs, the Jungian typology for the heck of it, What are the reliability coefficients? Or if you're having two raters look at someone and the level of agreement, right? If there's zero agreement, then we see that's equivalent to chance. We're in the coin toss. 0.1 to 0.2, so 10 to 20% slight agreement. Move on, and this is the area where I was talking about when we use two raters rating subjective performance using a rubric. We want to fall in the area of 0.61 to 0.8, that's substantial agreement. And that's what we would shoot for. Now notice these numbers, take it with a grain of salt, because different tests, different situations might yield different fine-grained analysis of this. But the 0.7, 0.75% is kind of the gold standard we use in social sciences and is probably applicable to most areas. The proper interpretation of reliability coefficients depends on the type of reliability being assessed and the purpose of the measure. For example, medical diagnostics require higher levels of reliability, and that is interpreting x-rays. So this is something where if you are teaching people, if they're taking classes in radiology and they're interpreting x-rays, then you want a pretty high level of reliability, right? Other things maybe are not so critical in that regard. So reliability then, what do we see? Refers to how dependable or consistent a measure is in assessing that particular characteristic. Measurement error can influence reliability. So to what extent does, if we want to measure this table and we're using an instrument like a yardstick to measure it, to what extent do we in fact get the same measure each time? Give an example of this. Long time ago, yeah, in fact, when I was at the shooting range, we decided we were going to install lights for our trap range to increase our business. And this meant that we had to sink 2 telephone poles 5 feet deep into the ground, and they would then extend 35 feet up in the air. They were 40 feet tall, and then the lights would be mounted on those. One of the guys I worked with was an engineer, old school engineer, and he brought out his transit. He loved this. He was having a great time. He used the transit, which he called the smart end. I took the stupid end, which was the stick that I hold out there, right, and he moves me around. And it was weird because he kind of took me by surprise. I didn't understand this. I was young at the time. And I would do it, and then he would say, okay, yeah. And he would get the reading. And then he'd say, okay, take the stick away and go back to the same spot and do it over again, right? And he would get a second reading. And then I would do it a third time, and I'm like, what the hell are we doing the same thing 3 times in a row? He said, because what I'm going to do is I'm going to take the 3 measures, because let's assume the 3 measures are imperfect, and then I'm going to average them. And he said that will give me a more precise measure. And it was all said and done, right? He came back out after we sunk the poles and concreted them into the ground, etc., and he measured them, and he said, you know what? We didn't do too bad. We're an 1/8 inch off. An 1/8 inch from perfection. And these 2 poles were 40 feet apart. I was astounded that it was that well done. But he was concerned about the measurement reliability, so in this case he used multiple measures, right, and then averaged those measures to come to what he believed would be the most reliable measure. And it appeared to work. It was pretty crazy. So measurement error influences reliability, and that's what he's trying to assess here. This might be in terms of reaction time. Any number of things. If we're having a forklift operator set something down and we want it done with precision, then we might have them do it 3 times and take the average to somewhat increase the reliability. To evaluate the measure's reliability, you should consider the type of measure, right? The type of reliability estimate reported in the literature about the measure, and the context in which the measure will be used. That is, to what extent is this important or not. So again, our statistics training comes back to haunt us. You see Penelope's come to visit us. So, hi Penelope. Yeah, sweetie. This is also Archie's sister, in case you're wondering, Marissa. Archie came from a big family, 7, huh? So, standard error of measurement is the margin of error you should expect in an individual score because of the imperfect reliability. So when we look at this, it's the variability surrounding the measure. So, and we see this in polling, right? Polls say, hey, the margin of error, right? This is what we believe. There's a 30% chance, plus or minus 3%. That's determining the margin of error, so to speak. Standard error measure is a more technical term, right? So, it represents a spread of scores you might have observed had you tested the person repeatedly, and this is something you determine statistically. The confidence interval, which I'm a big fan of, represents a degree of confidence that the person's true score lies within this range. So when I teach 45-20, 5-20, what have you, I require all the students not only to report the standard deviation, you know what we're talking about here, but I have them calculate the confidence intervals. And what this is saying is 95% of the time, the number that we're measuring will fall between these two boundaries within this confidence interval. The lower the standard error, the more accurate the measurements. If the SEM is 0, then each observed score is that person's true score. Again, this is something I want you to look for in the find and measure paper. I want you to be able to report, if it exists, hey, here is the standard deviations, the standard measure of error, the confidence intervals, whatever is available. This is how you vet a measure. This is how you determine the quality of the measure. If a measure hasn't been tested for reliability, then you probably want to wonder, A, why hasn't it been tested for reliability? Or perhaps it has, and the person who's selling me the measure doesn't want to comment on that because the measure does demonstrate unreliability or a low level of reliability. Or do they just not care, or are they not into the science thing, and they just like the measure because it sounds really awesome? So pay attention to this. Yeah, she's a cutie, isn't she? She needs to go in and get spayed pretty soon. And yes, she's a poor little one-eyed kitty, so they will also do some work in there, right? You and Willie both. We got validity next, so let's do validity as a separate chunk here. So I'm going to sign off for now. I think I got to get ready. I got to go take the electron to the vet so he can get his stitches out. So you guys, I'll see you in a little bit.